First motor type we'll look at here is a permanent motor in the field. Okay, so oftentimes these are called field coils. In this case, they're a permanent magnet. Okay, so they're constantly creating a magnetic field, and when we supply power through these coils, through the armature, we create another magnetic field. They interact with one another, and that causes our rotation. So here's an alternate version where we have an offset brush or a third brush, which will give us a 2-speed motor. So by offsetting the brush, we decrease the amount of time that there is power being conducted through the coils, which slows things down. So you can see a little switch occurring here, high speed, low speed. So our low speed is our offset or purple wire here, our offset brush, controlling speed. We also have the resistive type control. So this is common with like a blower motor fan and certain types of motors. We actually have varying resistors. Currently we have no resistor, so we have high current flow through it. If we slow it down, okay, we can see that we're adding resistance as we go, which decreases the current through the motor. And then of course we have our off switch as well. So by controlling the current flowing through here, we're also controlling the strength of the magnetic field, which increases or decreases the speed of the motor. And then the last control we will look at here is the pulse width modulated or duty cycle. Okay, so in this case, it'll actually turn on and off very rapidly to control current, or control on time, I guess would be more accurate. Okay, so here we're operating somewhere around 50%, so 50% on, 50% off, 50% on and off. This is occurring so quickly that it's difficult to actually see a difference, but it does impact the motor. So essentially we're turning the motor on and off. If you can imagine a switch opening and closing rapidly, half the time it's on, half the time it's off, and that's what we're seeing reflected here in this graph. So if we have more off time than on time, okay, we're going to have a slower speed. And if we have more on time versus off time, so this would be, say, a 75% duty cycle, and then 25% of the time it's off, 75% it's on, 25 it's off, we get a faster speed. And then if we are just full blower, 12 volts, high speed, just a constant 12 volts is going through it. So that's how a pulse width modulated control works. And then we'll have a quick look at the different types of fields. So here's our permanent magnet. Okay, and we're only supplying electrical current through the armature to get this to spin, because these always have a magnetic field because they're permanent magnets. Then we have the series type. So this is common for starter motors. This particular one has a field coil, so it's not a permanent magnet. We're actually generating this electromagnet by putting electricity through it. So it goes through the field coils first, and then it goes to the brushes, then it goes through the coils inside the armature, and then it goes to ground. So it's all wired in series. It has to go through the field coils first, and then it can go through the brushes and the armature. So we create two magnetic fields. Both are being created electrically, or they're electromagnets in this type. So that's most starter motors. And then we have the shunt type, which is just a parallel arrangement. So it's feeding separate power to the field coils and then a separate power to the armature. Okay, these are not as high torque as the series motors are. Okay, so wiper motors, window motors, things like that. And then compound. So this would probably be the most popular that I'm aware of for heavy duty trucks. Very, very high torque. And depending on the exact design and wiring, they can provide varying levels of torque and power output. So this one's actually a combination series and parallel. So they'll call them compound wired, but it's essentially a series parallel arrangement, and they do vary a little bit. But here we can see that there is a branch going to both field coils separately. One of them has its own ground, okay? And then the other one here is also feeding the brushes. So it must go through a portion of the field coil to feed the armature and brushes of the coil. So it's kind of a mix of both technologies. And these provide a very, very high torque, very good for heavy duty diesel engines, so very common in them.